Hello class, Dr. Mike here for Introduction Operating Systems. So this is chapter 1, usually week 1. It's Intro to OS for the textbook, chapter 1. What we're going to cover really is overview of the architecture. And I'm going to skip over yesterday's operating system. You can look at that. And we're just going to touch upon a couple of today's, and we'll touch upon mobile. So in any case, we will start off here looking at this chapter 1 in the slides here. We're going to look at the hardware level and some of the firmware. So first off, you can see here we have some definitions here. An operating system itself, it's a collection of programs or a collection of services, sometimes called, or which occur processes, and we'll go into that later. These services, apps, programs, they control interactions with hardware, and they of course interpret commands from the user, and in turn get the computer to execute commands that the user wants. So an application or an app, this could be almost anything. Word processor, spreadsheets, database. We know the word app definitely for mobile, but an app itself, it was actually called the killer app back in the day. Just a quick little history here. Back when the Apple II first came out, and I know Apple got the first rights, believe it or not, they got the first rights for Excel. I know you think Microsoft Excel actually was on the Apple, maybe not Macintosh first initially. And of course, this is all with a deal with Microsoft. But it's called the killer app because it sort of sells the system now. Nowadays, everyone needs a computer, really. Back then, you needed to justify the $2,000 to spend for a home computer. So Lotus Suite, things like that were called the killer apps. But anyways, and that could be the same thing. I can sell a phone, right? You know, the app, or in this case, the hardware for a phone might be like the screen resolution. Of course, the camera is probably the biggest thing. So, but anyways, I digress here. We'll go back. A computer itself could be anything. Microcomputer, computer itself. It could be a large server, rack-based server with attached components, but it usually has something called a CPU. As well as other components we're going to talk about in a second. It could, of course, be as small as a thumbnail. There's some tiny computers out there now. So, integrated circuit IC is what really drives everything today. So in case, let's actually look at and talk about the different parts of a computer here. So we'll try to keep the slides going with this too. So first off, let's talk about, this applies to almost anything on a computer itself. It could be from a smartphone to a server. We have a main part, usually called a motherboard, or it could be called a logic board. Depends on the manufacturer, depends on it. And like Apple phones, or even a lot of phones called logic boards, motherboard. This is the main, where everything connects. And externally from this, we probably have something called a PSU, a power supply unit. This is going to go on and give us power. And this could be from a wall. This could be from a battery for a phone. So that goes in and is regulated by the motherboard. The main part here of our system is called the CPU, Central Processing Unit. It's going to operate on a certain scale of frequency, usually in gigahertz, megahertz, so on. So a 3 gigahertz is 3 million cycles per minute. Each cycle, when this thing computes, it actually goes in and does 3 cycles. It fetch, decodes, and executes. So fetch, decodes, and executes. It does this on every cycle. So the more cycles, the more it can fetch, execute, decode, and execute. Hence, the faster the CPU. And of course, it's going to be more power draw, right? So the faster this goes up, the more power we're going to use. The more power we use, the more battery we drain. If our power supply is a battery, then we're definitely going to tap into that battery there. So I'll make that little D-cell battery. How's that? So our CPU itself has a measurement of speed in gigahertz, megahertz, and so on. Also, there is a measurement of cores. So we have now the ability by the manufacturers of CPUs to shrink down so small that in the footprint, it used to be one single CPU, can actually use 4 CPUs per se. It usually referred as cores. Multi-core CPU. So each one of these can actually perform calculations, a fetch, decode, and execute cycle individually. So really, back at the old 486, 386, 286 days, it was one core. So really, it was only able to do one thing at a time. Now, of course, even at 400, 500 megahertz, still pretty fast. As a human, we could distinguish. If I clicked on one program and changed it, it was in microseconds, milliseconds. It was so fast. But still, you can only push it so hard. So now we have multiple cores, and 3, 4 core, quad core, 8 core, multiple cores, and then the cores themselves can run multiple called threads. And I don't get too much into threads, but called multi-threaded, which actually is a way to optimize this fetch, decode, execute cycle. So it could usually use 2 threads per core, multiple cores per CPU, all running at a certain speed. So CPU, the main component there. Our next component, very important, is called RAM, our random access memory. This is our temporary memory when the system is on. It is what stuff is held. Our instructions, our code, our bits, our bytes. So that's actually measured in that. It's measured with zeros and ones. This is a bit, right? So if you take 8 of those, we have a byte. And we have 1024 of those. We have a kilobyte, and so on. So 1024 kilobytes, we have megabyte, gigabyte per billion, terabyte, and petabyte, and so on. So this is a 1024. This is an 8-bit scale, so it actually increases. So 1024 kilobytes is 1 megabyte. 1024 megabytes is 1 gigabyte, and so on. So this increases down the scale. We'll see this terminology used in RAM, as well as our next item here, which is our hard drive, our storage. It uses the same type of structure for storage. So we store in 1024, 512 bytes, so on. I'm not going to go into the hard drive structure yet, but I say hard drive, it could actually refer to the spinning cylinder drives. But really today you see is we have solid state drives or SSDs, which are a lot faster, way faster. So in any case, our drives, we keep stuff permanently. Our OS will live on there, our operating system itself, as well as our data and other stuff, other supporting files. There's a part of it called a virtual memory or swap space, which sort of works with our RAM. So our virtual memory or swap space, depends on the operating system, what you call it. It takes a chunk of our hard drive and sort of lets RAM write to it real quick and back and forth. So it gives you like a sort of a buffer to deal with. So our RAM, again, if we shut the computer off, RAM is wiped clean. It's gone. This is very fast. This is where everything happens. All the main, fetching, the decoding, executing happens. When you click save, for example, in Microsoft Word, we were saving to disk. And this is all done over this thing right here, which we call a bus. Our bus is sort of what connects, it's the highway that connects everything together. And everything together, our CPU and our bus operate on 2 different architectures. We have 32-bit and 64-bit. Now, 64-bit, being the newest, is probably what you can see now. This is our bus here. We'll fill it in. So, but it is possible to run 32-bit. You might see applications run this. You might see actual old hardware, old desktops that run 32-bit. Now think of this how wide the bus is. Think of this as a highway. It's 32 lanes wide. It can pack in 32 lanes of traffic. 64 wide. It can have 64 lanes of traffic. So you can push more back and forth. So that's really what it means. It also means we can have more RAM. because the upper limit of here, 32-bit, it's about 4 gigabytes of RAM at 32-bit. That's because the number itself, how we address the RAM itself, can only be addressed up to 4 gigabytes. That's all the space you have in 32 gigabytes to hold all the addresses. Almost like a phone book. It can hold only so many phone numbers. Yeah, old school phone book, I know. 64-bit, it's huge. Textbook will probably cover this. It's huge. You can have, terabytes of RAM. But old school systems, 4 gigabytes of RAM was a max. So our bus connects to our hard drive, and as well as any other components on our system. So in case we have things that, last thing here, hard drive is a very important chip besides our, you know what, I'll do this for a chip, right? The old connections to the board. We have another chip here, very important chip set, and referred to as the BIOS. The BIOS or the UEFI, more up to date. So it's the basic input-output system. So you first turn the computer on, the BIOS comes on first. And it'll check, say, hey, and of course it connects to the bus too, like everything else. It'll say, hey, CPU, you there? CPU goes, I'm here, good to go. I have my 5 volt, I have my 3.5 volt, I'm operating, everything looks fine. RAM, are you there? RAM goes, I'm there, everything looks good. And it goes, okay, is there anything to boot from? It'll say, all right. It'll say, is there anything in the USB drives to boot from? No? Okay, how about hard drive? Anything in the hard drive to boot from? And hard drive will say, yeah, I have an operating system here. But it's okay. It's all you, and it's called the second stage now. It goes, all right, operating system, whether it be Linux, Mac, Windows, take it over, and then the operating system will load up, and it takes over. So our BIOS, or UEFI, is our initial chipset, and it holds things like the system date time, the boot order. Do I check USB connections for things? Or do I, where do I boot first? As very other low-level configurations for your system. So that's our BIOS and UEFI. Some other things we look at. So important thing here we'll see is I/O. See on the slide there. Input, output. So those sort of things that we see coming into our system. Well, right there, keyboard, mouse, a touch screen if it's a touchscreen device, maybe like a phone. Output, pretty simple. Output we have, of course, audio, video, maybe a printer. Another input-output device we have, I'll put over here, which is very important, is our network. It could be a device built into the motherboard, an actual card, or it could be on our phones, like an antenna for Wi-Fi, or multiple. You might have a laptop that's got both a physical connection and a Wi-Fi antenna. Our network has I/O built into it also. So this, of course, connects into our bus. I'll try to keep my graphic getting too busy here. So you can see here, we have our RAM, our next memory, our motherboard. Covered that already. Input, output. Microphone's another one. It's both input, touchscreen, touchpads, so on. Firmware. This is what the BIOS is. So this is our firmware here. This is our firmware sitting here. Now it could be updated. Firmware being it's not software like on our hard drive, like our operating system or our data files. It's sort of burned into the chip, but it can be changed. Very often you need to actually change your firmware. I don't suggest doing it unless you have an issue. And of course you will consult with your vendor on this. So devices. So let's talk about devices. All kinds of devices for I/O. Some things about input output I'm going to talk about. When it comes from slow to fast, slow to fast, like from our hard drive or our RAM to our CPU, it has a cache. Slow to fast, you get a cache. And you'll see this in CPU specs. It has different levels of cache, L2 cache, level 1 cache, which is a small amount of space. The idea is I want to build up stuff, code in my case. I want to put chunks of code ready to be executed here so I can quickly get into the system. So what's called a cache. If it goes from fast to slow, it's a buffer. So fast to slow, and let's say our printer, for example. I'll draw a printer here, my best drawing ability. I know you're laughing right now. Yes, that's my printer. So our printer here. Our printer is slow, right? It takes time to print. Even the fastest printers you can buy still takes time. And they'll never keep up with our computer. So we've called it a buffer. So it's from fast to slow, it gets a buffer. So a print buffer is a good example of that. Now everything has buffers or caches. And it could be within RAM, some of the stuff. It could be within a hard drive. It's going to depend upon how your application is set up and how the hardware is done. So here's an example of our BIOS firmware you can see here. Phoenix BIOS, it's an old one. You first boot your computer up, you might not even see this screen. A lot of times you have to hold like a F12 or some sort of hotkey to get to your BIOS. Most of the time you don't even see it. So in any case, before we move into part 2 here, USB ports, input I/O, right? We have I/O there. CD-ROM, DVD trays is another one, which is still around. I'll try and do my best to draw an ejected CD-ROM tray. Those are going to the wayside though. But in any case, operating system. Let's talk about one component here. We'll talk about it again. Our operating system is installed into our hard drive, unless of course it's booted off in like a USB key. That's called a bootable OS. In any case, where our operating system is, it has something called a driver. A driver is a piece of micro software, small piece of software that you don't really deal with directly, that allows the operating system to talk to hardware. So ROS doesn't understand how to talk to HP printers, for example. It has some basic printer stuff. Our operating system has some basic printer drivers. It can maybe print a basic page, but it doesn't know how to work the scanner. So our HP, let's say Hewlett Packard scanner comes with some software that has a driver you install and helps the operating system scan data into it. Let's say if you use a scanner function, or print more advanced printing functions. Probably the biggest one, which is an output device, is our video card. I'm a gamer, so if you're not sure, love my gaming. I have a SLI video card system down here, old one though. But video cards, these plug in our system, of course, and the output will be to the monitor, right? Our biggest video outputs. That's a really horrible picture of a monitor. So operating system can go ahead and it can display, basic, pretty high def, but to really press, to do 3D graphics, things like that, maybe for gaming, maybe for audio, video editing. The video card itself has its own memory and so on. And to really work this, you need to have a video driver. So if anyone's any gamers here, I know there's a few gamers here watching this. Video drivers are the one thing you probably deal with, and I've updated for latest games. But in any case, that's an example of a driver, a piece of driver software. So look at the rest of this here. All right, so the way I wrap this up here, how's our stuff look? I'm going to do a new page here. So look at that, it zooms out. How cool is that? All right, so a server, pretty straightforward. A server could be a web server, a print server, you name it. You usually don't see Mac as servers anymore. Linux, Unix is still around. We'll talk about Unix later. But Linux and Windows are the two big servers. Linux is really huge. Windows servers are really huge. Email servers, print servers, these are the things that run our networks. Network server, for example. And of course, our client. It could be our phone. Our server sits out here. It could be on the web. It could be in the cloud. It's a horrible picture of the cloud. It could be within our network in our home network. It could be a, it could be a printer that operates as a print server. It could be an external hard drive you use to store stuff for the whole house. Of course, a corporate network. We have network servers, firewall servers, and so on. In any case, a client will connect to and operate, whether it's over the web or it's over the local network. And sometimes these things are transparent to us. Later in the course, we're going to talk about networking. But in any case, pretty straightforward. Server, client, and our client can take several shapes: desktop, laptops, mobile, and so on. Operating systems. Talk about those in a little bit. Windows, Mac, Chrome, so on. And you'll see the term PC, which really refers to almost anything. A personal computer is just that. And a Mac is referred to as a Macintosh. Mobile device, just that. Our phones, tablets. And embedded operating systems. These are really quick or system on a chip. These are real specialized systems used for like manufacturing, things like that. So, big thing here, Internet of Things. This is our Amazon Echo, Google Home. These are running operating systems, usually Linux, and they have even thermostats. They have full-on operating systems. They have networking, and so on. So we'll come back to this in a second. In any case, that's an overview of our sort of hardware architecture and everything goes with it. So part 2, we'll talk about the operating system.